Recording. So today we've got a lot to cover. We're going to be discussing chapter 13. Actually, I need a reality check from all of you. We finished chapter 12, right? I think.
What was the end of chapter 12 about?
Yeah, let me open it up. It was experiments with multiple variables.
Yeah, like bivariant and stuff.
More than bivariate. Where did you guys all go? Here you are. Let's see. The end of the lecture, we were talking about main effects in three-way designs. And I was talking about like the main thing you guys need to remember. Did we talk about this? Maybe we didn't.
No, I don't think so.
Okay, with someone with notes, take a peek.
I'm pretty sure we just finished we did chapter 11, part 2.
So we haven't done any of this experiments with more than one independent variable?
I don't think so.
Okay, so we are buku. Okay, well, step one, I'm going to talk to you guys about the discussion section. And then we'll dive into lecture, and whatever we cover today, we cover today. If not, we cover it next week. We're not going to lose sleep over that. Okay, can you guys all see my Course Connect page?
Yes.
Okay. So we are going to be covering, oh, that's why, because we had our group meetings last week, but then I thought, anyway, we must have finished that. So we'll cover chapter 12 here. I'll bring it down here so that it's a little clearer. I did add a results section Dropbox so that you guys can submit your assignments there. I apologize. I thought it was on there and it wasn't. And I've had a handful of students tell me like, we're supposed to email it to you. Like, how do you want it? So that is my apology. It is there now. So you can go ahead and submit it right here. If you submitted it to me via email, I would greatly appreciate you also submit it here. It just makes grading so much easier. And sometimes I lose track of stuff in my inbox because I get so many emails. Right here, this is what we're going to cover right now. So you see the discussion section must-haves. So as a quick reminder, your results section is due by midnight tonight. And the discussion section is going to be due next week, which is the 21st, okay? So for the discussion section, what you're really working on is explaining away the results. And so I just want to walk you guys through, this is just a resource I found online that could be helpful as to what it is you need to have. So if you click on this link, it'll bring you here. And that's USC's library as to how to discuss specifically the discussion part of your paper. So I want to go over this briefly. So the purpose again of the discussion is to both interpret and describe the significance of your findings in light of what was already known about the research question that you had. So you're taking all the results that you obtained and outlined in your results section and really breaking it down as to what does it mean and how does that relate back to your hypotheses and back to the original literature review and what you wrote in your first section for your literature review. The discussion section is often noted as the most important one. I would say that and the results section. It really bothers me when students just read the discussion section and don't look through the results to make their own interpretations. You guys are smart, trust yourselves and the training you've had. But the discussion as a whole, when you as a researcher are reporting the data, that's where you have a chance to really bridge the gap between what the literature told us and what we already know, and then what we discovered and how that's advancing science as a whole. Okay. Okay, I'm gonna jump down here. So the structure and writing style, okay? These are just some general rules to follow. In your discussion section, try not to make this the greatest American novel. You do not need to be super verbose. You are really just outlining and unpacking your results section. Try to avoid jargon or undefined technical language. In our particular research project here, I don't think this is going to be an issue. Make sure to follow a logical stream of thought. This is something that drives me a little bananas because people will be like, and then this happened, but this is a limitation. And then this happened, and then this is future research. No. We're going to keep everything of what happened, right? Describe your results. And we're even going to have a subheading that says description of results. You're going to write it out all underneath there. And then we'll have a separate section that says limitation. Well, you'll highlight all the limitation. Then we'll have another section that highlights future research. And I'll go over that in just a minute. Just don't jumble it all up. It's just cleaner and easier probably to both write and to read. So that's something I would keep in mind. All right, so what is the content of the discussion? So first you are explaining away the results. So let me read this here. You want to comment on whether or not the results were expected for each set of findings. So remember what your hypothesis was in your literature review. You will need to connect the results back to that. You want to go into greater depth to explain findings that were unexpected or especially profound. So again, we may not have talked about this. Did we talk about null effects? I think we did talk about null effects last week.
Yes, yes, we did.
Yeah. So with null effects, it doesn't mean that that's bad or that somehow, oh, well, throw your hands up. You're a terrible researcher. Go find a new job. McDonald's is hiring, right? That's not what it means. Sometimes the greatest finding that we can find is when the null hypothesis is supported, when we cannot reject it, and our research hypothesis was in fact incorrect. So make sure to go over that and talk about that. And this is an opportunity to also insert some of your secondary hypotheses, right? Let me give you an example. So I posited my hypothesis was that men, I don't know, males would be more likely to work out 5 times per week compared to females. And males, my hypothesis was they were more likely to eat lots of snacks compared to females. And I'm making stuff up here. So let's say that was my hypothesis. And then I found quite the opposite. I would need to note that and say, so my hypothesis was not supported. In fact, we found the result. Some hypotheses as to why we had this finding may include that the proportion of female athletes on our campus is, really disproportionately high compared to what the literature review talked about. And so as athletes, they are working out more often, and perhaps because their schedule is so packed, they have less time to snack. Truly making things up here. But this would be a way where you're describing your findings, you're connecting it to your hypothesis and how that didn't link up, and then you're coming up with an alternative reason, or you're putting it in the context of the environment that you're in, or specifically your participant pool, to explain away that result. Okay, does that make sense?
Yeah.
What I'm describing? Okay, all right. You want to, this next section here says references to previous research. You may skip that, okay? So in fact, let me just make it very clear in case somebody is just really quickly looking at this lecture. You may skip that. The reason why is for our study, we're not diving in that deep. So referencing past studies is not going to be as meaningful. There's nothing that's going to be identical to what you're doing. So we don't need to worry about that. A deduction, that's a claim for how the results can be applied more generally. This is, again, external validity. We definitely need to hit on that. So describing what you've learned, proposing recommendations that can help improve a situation or highlight best practice. So these deductions, that would include limitations of your study and areas for future research. Lastly, you also want to connect it back to the hypothesis. Again, how does this loop back? So you're really doing this already in the explanation of result. That could be a nice tying of the bow in a conclusion sentence, right? We had originally hypothesized, blah, 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 blah. In our study, we found X, Y, and Z, in fact, supporting or refuting our original hypothesis. As such, we are looking forward to future research in departments A, B, and C, just broadly. Okay. In terms of organization, what's going on here? It's not letting me scroll. Now it is. Oh. Huh. That's not helpful. Okay, hold on. Let me erase this. Okay. And moving right along. All right, organization and structure. Okay, so this is going to be key. Think of your discussion as an inverted pyramid. That's almost like any research paper you write. You start big and you narrow it down to a small, more finite and precise aspects. You want to organize the discussion from the general to the specific, linking your findings to the literature, then the theory, then to practice. Again, we're going to take this a little loosely because this is a class project. You want to make sure you're using the same key terms throughout. If you talked about depression symptoms, don't all of a sudden call it feeling blue, right? Like stick to the same language. You want to keep the same narrative style and verb tense that you use when describing the research problem in your introduction. So you're just keeping it. So if somebody's reading it from start to finish, it's going to make sense to them. You want to begin by briefly restating the research problem that you're investigating, okay? This is going to be key. And then you're going to want to answer all of the research questions underpinning the problem that you pose in the introduction. In other words, you want to say, here's the issue. This is why we're interested in it. And then here are our hypotheses. Next, you're going to describe patterns, principles, and relationships by each major finding. Okay. So the first step might be to report in our sample, we were able to get an N of, write what that is, and you can start breaking it down by your demographics, right? Our sample ended up being quite unequal. We had 85% female and only 15% male. So because of that, we are seeing this. This is how our sample broke down, but later on in the limitation section, that's an area you can talk about, that you didn't have an even split in gender, for instance. Then you're going to talk about what specific research findings you came up with. So talking about the averages that you received, any special analysis that you did in regards to specific questions on your survey. Okay. You want to make sure to include unexpected findings. Anything you did not expect needs to be highlighted. Okay. Again, this is going to be your overall goal, right? You're describing everything. This is going to be a separate subheading where you're talking about the limitations and or weakness of your study. Now, you may think you did a phenomenal job, and all of you guys did, but in any study, no matter how good it is, there are always limitations. So talking about sample size, talking about a non-matched groups in gender, let's say, or athletes, or am I frozen, you guys? Or can you hear me still?
No, we can hear you.
Okay, good. Just all of a sudden I thought, let me double check. Any of those aspects, right, about your study, maybe the survey was really short, so increasing the survey size. Maybe people dropped out. They only responded to, 50% of your survey. So, right, attrition would be an issue. Anything you can think of with limitation, I would include in there. And then you want to make sure to have a future research section. I'm trying to see if that's what. Yeah, this can be followed by recommendation for future research. So based on what you found, what would you do next? If there was a round 2 of this research, what would you do? Would you change some of the survey? Would you add in an additional survey? Would you recruit participants from a different area? Maybe do a comparison, like these are all college students. Now I'm interested in older adults. So recruiting from that pool. This is what I mean by future research. Okay. All right. So, okay, right here, this highlights it pretty well. Section 1, reiterate the research problem. Section 2, what does the report, what do the results mean, right? Why do we care? You can skip this relate from the findings similar study, just skip that. Consider alternatives, explanations. So that's for any of the unexpected results you get. Then you talk about limitations, and then you talk about future research. Those should be the subheadings that you include. Okay. So again, you can use exactly these titles. I don't have a problem with that. The only one we're skipping is part 3. We are not relating the findings to similar studies, but we are reiterating the research problem. We are explaining our findings. We are explaining unexpected results. We are talking about limitations, and we are talking about future research. Those are the subheadings you need. Okay. The bottom section you can read at your leisure. This is really the meat and potatoes that I think we need to cover for the discussion section. Any questions from anyone?
All good on my end.
Okay, anybody else? No, all good? Okie dokie, artichoke. I'm gonna move that down. Obviously, as you guys know, you can refer back to this slide, or this link is under this week. It's called Discussions How-Tos. You can click on that and it'll open it up so you have access to it. All right, so let us jump into this particular, where is it? Story of my life. I'm always like, where is it? I have too many screens open is my issue. Okay, can you guys see this? Experiments with more than one independent variable?
Yep.
Okay, now I need to figure out. Do you see it really big?
Yes.
Okay.
Really, really big.
Okay, good. All right. So we've talked a lot this semester about how to set up research, independent variables, working towards dependent variables, understanding what that all means. And then we've talked about bivariate correlations, or bivariate, like two specific like correlational studies. But in the real world, when you're running studies and doing research, it's very rare that you only have one independent variable that you're looking at. It's far more likely that you will have a slew of them. Because again, if you think about social sciences as a whole, how often do we say, well, what leads to this behavior? Oh, it's just this one thing, right? That's not something we do. It's really layered and requires a lot of nuances and has multiple factors involved. So this is why we're going to spend a little bit of time as to how we figure out how to do research when there are, in fact, more than one independent variable. All right, I'm going to make our faces small because it's covering everything up here. All right, so here's a quick overview. We're going to talk about experiments with one independent variable to just refresh our memory on that. And then experiments with two independent variables to show again when there is an interaction between the two. We're going to lastly talk about factorial variations. We're just going to touch on that briefly. And then we'll talk about how to identify factorial designs when you guys are reading research articles so that you're at least familiar with it. All right, so let's take a quick review as to what is an experiment with one independent variable. So this is from your textbook. They talk about kind of this idea of, are people angry drunks, right? Do they show aggression when they're drunk? So the placebo group, which is this one right here, the pink column, they ended up drinking orange juice with a very small amount of vodka in it. And the alcohol group, as a comparison, drank enough vodka to reach a 0.10 blood alcohol concentration. So let's just refresher, what is the legal limit?
Isn't it like 0.07?
0.08.
Yeah, I was thinking it was 0.08, but maybe you're right, Christopher. Did it drop? Maybe it's even less. So these people are quite inebriated at 0.10, right? So then, again, who's like, ooh, I'll sign up for the study. That sounds kind of nice, right? Just drink and then observe my behavior. Not that you should be drinking. I think most of you are probably under the age of 21. Forget I said that. But so then they created these two groups, right? You're either going to be in the placebo group or you're going to be in the drunk group. And then they had them play a video game. And then there was an opponent they were playing against that was in another room. Now, the truth is this feels a little Milgram-y because there was no other opponent Like it wasn't a person. They were just playing against a computer. But they were told, hey, the person you're playing against is in the other room. When the player, aka the computer, made an error, the participant was to deliver a shock in punishment. Again, how much is this like Milgram? So both the intensity and the duration of the shock were measured. Okay, so that was kind of the test. So is there a difference in the length and intensity of shock that's given when you've just had a tiny bit of alcohol, aka placebo group, versus when you're really inebriated? Okay, that was their question. So what you see right here is the top graph right here shows, right? This is the intensity in shock from 1 to 10. The placebo group averaged it right at as a 5. The drunk group averaged it at a 6. Excuse me. In terms of duration, you can see the placebo group averaged just below 1 second, whereas the drunk group almost 2.5 seconds. Okay. So what are these graphs? What are they teaching you? What do you see?
Shows that when people are super inebriated, are more likely to hold down that button for longer or are angrier.
Okay, good. Can anybody think of some hypotheses as to why that might be the case?
Like when you're very inebriated, you're not thinking, you're not as compassionate as you might be otherwise.
Okay. Yeah. So then you might be more aggressive or show greater tendencies towards, violence or aggression, like hurting somebody else. Good. You guys, I'm turning on my heater. I'm still freezing. Judge away from your faraway location. All right. Any other ideas?
People who are inebriated might just lose track of time quicker. So
Yeah.
they might just hold the button unintentionally longer.
Right. So there's, and I think we've actually shown studies about this in this class about reduced response time. Like your reaction time is going to be slower. So maybe they're like pressing the button, but it takes them a hot minute to, well, obviously not, it's like a second, but it's a little slower in responding. Right. Okay. So this is really indicating that the drunk group administered the shocks for a longer period of time and for a more intense shock than the placebo group. Okay. So this is an example of just one independent variable. We are switching our independent variable as to whether they're drunk or not. And the dependent variable is the intensity of the shock and the duration of the shock. Okay. So again, one independent variable, drunkenness really is it. All right. So let's look at this next one. The second one involves cell use while driving. So this is the amount of time it took for people to brake, right? So this is our dependent variable. That's what we're measuring. And this is whether they are on their cell phone or not on their cell phone. Now, I should specify the on the cell phone, it's not like they're like this, it's hands-free, but they're still on their cell phone. So the way they did the study is they had them in a driving like simulator. I don't know, I'm just picturing like a Dave and Buster like kind of driving situation, right? And then they were measuring how long it would take to brake. And then they had some that were talking on a hands-free. So I don't know if it was, earbuds or, some sort of Bluetooth thing. So they're talking on the cell phone and the other just no cell phone. So those are the comparison group. Now, what do you guys notice about this graph?
Those who are on the cell phone take a longer time to brake than those who are not on their cell phone.
Okay, good. So if we were to describe that, so you did a perfect job describing the results, what does it mean?
People's reaction times are slower when they are on their phones or when they're talking or concentrating about their phone.
Right. So, I mean, again, taking the bird's eye view, it would be like a distraction while driving reduces response time or reaction time, might lead to more risky driving, right? More sorry, we're really not picking on you here, Kyle. He's like,
I know. I just
And
thought
the
this was really
car.
funny. No. Also, by the way, I made it to my destination. I'm just waiting in the parking lot. So I'm
totally
not
fine.
driving, so we're good.
This is a sidebar. I had dissertation defense yesterday, but it was right before I had another appointment where I had to be in a building. So I left early and just parked. It was a nightmare. I was in East Town. Somebody came and knocked at my window to move as like my student is like shaking in his boots, like presenting his dissertation. So I had to like mute and talk to this ticket made person. Anyway, disaster. Yeah, but this is what we need to do sometimes. All right. So these are both examples of one independent variable. Again, the independent variable here is, are they on their cell phone? Yes, no. And then this is the dependent variable. Okay, but as I said, this is not the only, like in the social sciences, it's very rare that there's just one independent variable. So let's look at what it looks like with two independent variables. So when you have experiments with two independent variables, it can show you interaction effects. So it occurs where the effect of one independent variable depends on the level of another independent variable. So that means those two independent variables are interacting together, and that interaction is leading to a change in your dependent variable, okay? So this is, if you think about language-wise, it's not whether or not there's a difference. It's really saying, well, it depends. There's a difference if this, then that, right? Not there's a difference all the time. So in the cell phone study and the driving study, the one we talked about, you could add a secondary independent variable that would be age, right? So are you an older driver, younger driver? Are you on your cell phone or not? And what's your brake speed? Okay.
And sorry to interrupt, but could another one be like the traffic on the road?
Right, absolutely. And in fact, we'll talk about that in a minute. That's another piece of it. And again, if you think about the real world, my phone is just blowing up. The real world has multiple of those, or what's the weather, right? Maybe you're slower at braking if it's a beautiful day and you're distracted. Maybe there's a difference between highway braking versus city braking. I mean, we can come up with all sorts of ideas. So yeah, so that's how we would get an interaction. So let's look at an interaction right here. This is a crossover interaction, okay? So there's two independent variables, the food type and the food temperature. And the dependent variable is how much do you like it? So do you like food that's hot or cold? That would be one independent variable, right? Or do you like ice cream? Yes, no, that could be one. Now they're making this an interaction effect, right? Do you like ice cream when it's hot? Well, the answer here is not so much. Not ice cream soup is not my jam. But if it's really cold, right? It's right here. So this is the cold arrow. How much do you like ice cream when it's cold? A whole lot. How much do you like pancakes, right? When they're cold? No, it's rubbery. It's no bueno. If they're hot, oh, now you like it a lot. Okay. So there is a crossover interaction here. So if the question is, how much do you like ice cream? The answer would be, it depends. I like it when it's cold. I don't like it when it's soup. Does that make sense? Okay.
Yep.
This is another one where you, so this one specific, where is my cursor? This is a crossover interaction. These over here are interaction, just not crossover. So let's talk about them specifically. What is the dependent variable here? Let's see if you guys can figure that out. What do you think?
You said what's the dependent variable?
Yep.
Would it be the grain?
Would it be the portion of time dog sits?
Yes. This right here, the proportion of time the dog sits is the dependent variable. That's what we are measuring. We're measuring how long the dog is sitting. Now, there's two sets of independent variables. What are they?
Holding a treat
Stage
and then no treat.
So that's one of them. Good. What's the other one?
What you say to the dog?
Excellent. So whether you say something or whether you say sit. Okay, so let's look at this. If you do not have a treat and you say nothing, dog doesn't sit for very long. If you say sit, dog does not sit for very long. If you are holding a treat and you say nothing, dog doesn't sit for very long. But if you then say sit, there's a significant increase in how long the dog will sit. Okay. This information right here is the same one, right? We're just flipping it. We're flipping the independent variables one to the other. Okay. Do we see that? So if you're holding a treat, right, and you say sit, or you say nothing, sorry, dog doesn't sit very long. No treat and you say nothing, dog doesn't sit for very long. On the other hand, if you say sit and you're holding a treat, dog sits for a long time. If you say sit and you have no treat, the dog does not sit for a long time. Okay. So the lines here aren't parallel, but they don't cross over. Okay. It's not like this where they cross over. It's like an opposite effect. This one, they don't cross over. They're not totally parallel. We'll look at some parallel examples in a minute. So they're not quite like that, but this is showing us a spreading interaction. So whether or not my dog sits, when I say sit, depends on whether or not I'm holding a treat. Okay. So that is the way I would describe that as an interaction between the two independent variables. Okay. Now, factorial design is an experiment in which there are two or more independent variables. And in this case, they can also be called factors. Okay. So this is going back to the experiment we were talking about earlier. So the first independent variable is, are they on their cell phone or not? Or the first factor, right? The second one is the age of the driver, which then leads us to all these combinations. So these are the 4 combinations for this factorial design, okay? So you can use them again to manipulate variables or participant variables in this kind of design. You just make a square of all the possibilities. So then looking at the results here, if my independent variable, my first one is cell phone condition, whether or not they're on a cell phone. My second one is how old is the driver. And note here, it's not like you see there's 2 people that were 21, 2 people that were 23. It's not like that. It's categorized into 2 variables, right? Younger or older. Presumably that would be defined in the design of the study of how they classified it. We just don't have that information here specifically. And again, the dependent variable is the breaking onset time. So how long does it take them to break? All right, tell me what this all means. What do you guys see in terms of both? Yeah, the table. We'll talk about the table first. Uh-oh, does this not make sense?
Driving again,
Was
so
it?
I can't see the table.
Oh, no, it's fine. Yeah, go ahead, Elizabeth.
That there's not a whole lot of difference between the braking time of younger and older drivers.
Okay, so let's, oh, was somebody chatting here? No. So let's look over here. If they're on the phone, younger drivers' response time was 912 milliseconds and older drivers was 1,086. So which number is bigger?
The older drivers.
Right, so older drivers were slower than younger drivers when they're on their phones, right?
Mhm.
This is not like a mega difference, but it's still a difference. Now let's see what happens if they're not on their phone. Younger drivers are at 780, older drivers are at 912. So what are we seeing
More
here?
of a significant difference when the phone is not an interrupting variable in there.
Well, I think what we're seeing here is in both cases, older drivers are slower, regardless of this independent variable, whether they're on their cell phone or not. Older drivers are consistently slower at braking.
Yeah.
Okay. So this is not an interaction effect. It's not when they're on their cell phone, they're slower, right? It's not that. It is a main effect. So age has a main effect on braking speed. And the way we know that is the two lines are parallel here. So what we see is that that's what it's indicating, it's a main effect, because even if you switch the secondary independent variable, you are not seeing a swap or an interaction between the two of them. It's a main effect, okay? So overall, older drivers are slower at braking than younger drivers, okay? And you can also see that overall, both of them are slower if they're on the phone than not, because there's a decrease both ways here. Okay. Does that make sense?
Yeah.
Okay. So this is showing a main effect without an interaction. What's that?
Hey, Kyle, you're not muted.
I think your internet might be bad, bud. Or maybe it's my internet. I can't hear him.
No, I can't hear him either.
Okay, we're just gonna keep on trucking then. All right. You can test the limits when you're doing factorial designs. And one of the way is to do that with an independent form. And it's test the limits of an independent variable as a form of external validity. So again, the alcohol and aggression study, you could add on to that study, right? What if they wondered if the effects of alcohol and aggression really depended on body weight? Because this is a study back in 2010. They randomly assigned men to a drunk group and a placebo group, and then they measured their aggression through the shock intensity during the shock game we described earlier, okay? These are the results that we see. Now, obviously, they didn't randomly assign them to the weight category, right? The independent variable of weight, you can't randomly assign it. Just either you are a light man, which is 151 pounds and lighter.
Are they all the same age?
No, this one doesn't look at age, but I'm just thinking here, I don't know how they divided this because obviously there's a gap here. Maybe it's just lighter men, so under 151, or then we are looking at 215 and above for the other group. Now we can see here the placebo group, those who didn't drink a whole lot, the shock intensity went slightly down between light, like very light men versus heavier set men. The drunk group, though, we saw an increase. So lighter men didn't have as high of a shock intensity when they were playing the game compared to heavier men, okay? Now, if we go down here, right, and we replug those in, we're swapping these two, we can see there is, in fact, a moderating effect, okay? So if you are in the placebo group, you're not drinking a whole lot and you are heavier, right? This is the green bar. There's a significant increase in the shock intensity compared to if you're in the placebo group. So again, this is showing the same thing. We're just swapping the independent variables here from one to the other, so that when they're switched around, you see the effect of alcohol is stronger on heavier men, okay? You can also test this out as a moderator, as I describe right here. A moderator is an independent variable that changes the relationship between another independent variable and the dependent variable. So a moderator results in an interaction. So the effect of one independent variable depends on the level of another independent variable, okay? So the effect on drunkenness and the shock intensity depends on whether they're light men or heavier set men, How does that all sound? Does that make sense?
So
Yeah.
does it means like the heavier you are, the less you're likely to get drunk, or like
Good question. No. So this is saying the heavier you are, if you are drinking, you're more likely to be aggressive. You're going to have a higher shock intensity than if you are light. Does that make sense?
so it's more towards the behavior, like how you act after you drunk?
Well, this is
Bye
not just
bye.
this is not just broadly. It's it's mostly specific to the study. So remember in this study, they gave the placebo group orange juice with a tiny, tiny amount of vodka, and then they gave the drunk group a ton of vodka, and then they had them play that video game. And whenever the other player they're playing against got something wrong, they administered a shock, and they were measuring the intensity of that shock and how long they gave them a shock. So
Okay.
that was the measurement of aggressive behavior. That's how they, they had the construct of aggressive behavior, and they're like, obviously we don't want to see people getting in fistfights. So they developed this idea of playing a video game and giving shocks to not an actual person, it's just on a computer. And so by measuring that, that's what they're qualifying as aggressive. And then they're comparing it between the different drinking groups, placebo and drunk, and the different weight groups. And what they're seeing is if you're a heavier man, you are more likely to be aggressive than if you're a lighter man.
That makes sense.
Okay. For the exam, you guys don't need to know how to graph this. That's not the goal, again, of this class. It would be to understand and be able to explain it away the way I just did. So the discussing it depends. So it'd be including that if you are a heavier man, you are more likely to show aggressive tendency when drunk compared to lighter men. So it's explaining away what's being shown here as the interaction between the independent variables. Okay. You can also use factorial design to test a theory for alcohol cues. So this is another really interesting one. So when you test theory, you're making predictions about how variables might interact with one another. A factorial design is a good way to test that out. And one of them is with alcohol cues, and we'll just look at this particular example right here. So in this particular study, they were looking at if somebody was cued with a picture, so either a picture of alcohol or some non-alcohol related picture, they picked that as a neutral, or the placebo is a picture of a plant. Their question was, they're trying to assess, why does alcohol cause aggression? That's what they're trying to figure out. There's a lot of theories about that you could become, cognitively associated with thoughts of aggression. So they were trying to figure this out. This is a study from 2006. So they had participants view images and words on a computer monitor. They were to indicate whether a string of letters was a word or a non-word. Some of the words were aggression related and others were neutral. So before seeing each string, participants were briefly primed with a photo on the computer screen. Sometimes the photo related to alcohol, and other times it was a photo of a plant. It was hypothesized that participants would respond more quickly to identify aggression-related words if they were cued with alcohol. Okay, so it's testing two specific independent variables: the photo type, alcohol photo or plant photo, and word type, aggression related word or neutral word. So we could see that right here. This is one independent variable. This is the other, as laid out right here. Okay, now here's their finding. So again, we're looking at reaction time, how quickly they were able to identify the word. And what is this showing us? Somebody take a stab at it. What pattern do we see?
says it's like a neutral. Like having the points, like seeing the alcohol didn't mean that they were like aggressive, they were like neutral. Same with the points, they were like neutral, they like were like 50-50.
Okay, any other thoughts?
Maybe the word type affects reaction time, depending if it's aggressive or neutral.
Okay, so I want to make sure I understand. The reaction time differed depending if it's aggressive or neutral? Is that what you said?
Yeah.
Okay. So the way we would read this is we're looking at our two independent variables here, two independent variables here, and both of you had parts that were correct. We just need to combine it now. So when looking at how quickly they're identified, because this is our hypothesis, right? How quickly are they identifying aggressive words when cued with alcohol? Okay, that's what we want to know. That's the hypothesis. How are they, in fact, identifying aggressive words quicker if they've been primed with alcohol? Okay, so if that's my hypothesis, then what do you guys think?
I don't think it mattered it to them.
Okay, so looking at these numbers, 551, right? So this is an alcohol group. So if they were primed with the alcohol photo of some kind, the response rate to identify an aggressive word was 551 milliseconds compared to identifying if they were primed with alcohol, it took them 562 seconds to identify a neutral word. Okay, so they were faster at identifying the aggressive word compared to the neutral word. Okay, does that make sense?
Yeah.
Okay, now let's compare it because we want to use a control, right? Like it can't just be, oh, there it is. There's a difference here. Well, we got to see what it's like against this more placebo-like. So those who were then shown a plant or a neutral picture, it took them longer to identify aggressive words. As we could see here, 559 is bigger than 551. And it took them less time to identify neutral words. So in other words, if you're cued with a neutral picture, it took you longer to identify an aggressive word compared to a neutral word. Okay, this is what this table is showing us. Heading
Can I ask
down
a
here.
question?
What's that?
Can I ask a quick question?
Mhm.
So I'm a little confused on the I see the aggressive and neutral. That's looking at the word type, and then the dependent variable is if someone had consumed alcohol versus if someone had consumed plant.
Oh,
or-
no. Yeah, I can see why you would be confused. No. Okay, so they're measuring, there's flashes on the computer, right? So they're
Yeah.
shown quickly a picture of an alcohol related scene. Maybe people at a barbecue drinking beer. Maybe there's just a glistening glass of scotch or something. I don't know. I'm making stuff up here. I don't actually know what it is they use. Actually, I can find out. Let's see if they have examples of the picture in chapter 12. So they were then shown, they were cued with that just real quickly, right? And then
Yeah.
they were shown a string of letters on the computer and they had to rearrange them and figure out, is this a word? And is it a neutral word that they identified? Or is it a word depicting aggression? Okay.
Oh.
So maybe it said table, right? Like you had to rearrange the words. It's a table. The other one said stab. Okay. Again, I'm not quite sure what the list of words were. The idea is if they were cued with an alcohol photo first, they were much faster at deciphering the aggressive words.
Oh.
So it's showing that cognitively, even the imagery of alcohol and drinking and drunkenness is priming for aggression. That's going back to the theory. If you guys want to look at your, I don't know how many of you guys have your textbook around. The study is described on page 359 in some detail, but there's no example of the photos, sadly. But you can at least get the citation so you can look it up if you want, if you have time, and if you're that curious, you can look at it a little further. Okay, so does that make more sense, Elizabeth?
Yeah.
Okay, another question?
Yeah, I think what's confusing is like the 551. Like, is that like the number of people that respond, or is that like the time?
That is the time. So this is a good question too. Whenever you see one of these tables, these numbers are going to relate back to your dependent variable. So you can always go back here to figure out, somebody got kicked out, to figure out what's the measurement, right? Sometimes it'll be a number of people. There we go. But this
I
one is,
entered it was like,
what?
I thought it was like a number of people that responded.
Oh, no, this is, it's measuring it in milliseconds. So again, it's amount of time. So now let's look at the graph, okay? Obviously, this is ranging from a very, very short reaction time, 544 milliseconds, all the way up to 564. What we see is if they were primed with an alcohol photo, this was their reaction time for an aggression-related word. It was really, really quick compared to if they're primed with the alcohol photo, but they were shown a neutral word. Look how much slower it was for them to respond, okay? And the other way is if they were cued with a plant photo, just some neutral visual stimulus, they identified the neutral word fairly quickly, but they were slower at identifying the aggression-related word. This is showing an interaction effect, right? Because the way we could say that is when primed with an alcohol photo, participants were quicker to identify aggression-related words as compared to those who were shown neutral pictures identifying aggressive words, okay? This is showing it right here. Does that make sense? Let's try another one just to see if that brings it home for you guys. Here it is. Okay, this is a different study. This is done back in the 70s. The theory was learning and memory is context dependent, okay? So if you are in a certain context when you are studying and that context is similar to when you take an exam, you are more likely to do a better job at memorizing the content, therefore you'll perform better on the particular exam that you're getting. So that's their theory. What are the independent variables? Looking at this table, what do we notice?
Water's edge and underwater.
Yes, but what are the independent variables? So you're correct, those are the two, but what you need to look above beyond.
Recall condition.
Yes, okay, and the other one is the learning condition. So back to what I just finished describing, this is the testing environment where they had to recall certain knowledge. And this is where they learned the knowledge. Okay, so then this is looking, what is the dependent variable?
I'm gonna stop talking.
Yeah, oh
let
yeah, you
someone
can let
else
somebody
answer.
else. Yeah, that's totally fine. What do we
So
say?
what's the dependent variable?
Yep.
Would it be the memory score?
Yes. So that is the number of words they correctly identified. Okay. So let's put it all together. What happened here is they learned certain words, right?
Yeah.
I think that's what it was. I want to make sure I'm telling you. Yeah, it's words to memorize. I don't quite know what kind of words they were, but they are. So if they learn words on the water's edge, so right, these are scuba divers, again, super crazy study. There's scuba divers, and there's two learning conditions. So either they're learning the words at the water's edge, or they learn them underwater, okay? And then they were asked to recall, right? So imagine this. First, they're like, okay, I'm going to teach you these words. You need to remember these 20 words. Here they are. Practice them, memorize them. right? We're on the water's edge. Okay, now X amount of time goes by. Now we go back to the water's edge. Hey, do you remember those words I asked you to remember? What were they? And so that's their recall condition, right? That's the how well they were able to recall. So the question is, if the theory is that you are better at recalling if the context is the same as when you learned, what would you expect?
Would you expect the memory to be like better if they're in the same context?
Very good. Yes. I was like, you're on it. You got to finish that up. Yep, absolutely. So you would expect that their recall would be better if the context was the same as where they learned. Does this table support that theory?
No. I'm looking at the numbers in that chart and they are looking a little.
Go
would say
back to your
no.
dependent variable. What is it we're measuring? What's the measurement in here? It's this.
Yeah.
So this is saying if they learned on the water's edge and they recalled on the water's edge, they got 13.5 correct. But if they learned on the water's edge and recalled underwater, they got 8.6 correct. So did their performance increase or decrease by changing the environment?
Decreased.
Decreased. So this, in fact, would support the theory that you learn and recall better if the context is the same, because this score, and if you look here, underwater to underwater, this score, both of these, are higher than these scores.
Oh.
So they perform better if they are recalling on the same context as where they learned. Okay. So this is the exact same information just plugged into a graph. So if they learned at the water's edge, right? This is the blue line. They performed better in the recall at the water's edge. If they learned underwater, they performed better if the recall condition was underwater. And the inverse is true. So if asked, do people remember information better, specifically underwater, you would say it depends if they learn that information underwater. Okay, that's how I could do a summary sentence on that. Are you guys with me, or I feel like this might be a rough one? Okay, make sure to review this lecture then before the exam, because we'll have a couple of these on the test. Okay, so how do we then make sense when there is no interaction? Sometimes there's just a main effect, meaning is there an overall difference, right? There's an effect of one independent variable onto the dependent variable. If there's an interaction, you want to know, is there a difference in the differences? So we're highlighting a difference, but is there a difference at, a sub-level before that? All right, so let's look at some examples of that, okay? So these would be our marginal mean. So it gets in the weeds a little bit with the math. Don't worry so much about that piece of it. Let's just broadly, this is what we're looking at. So a main effect is the overall effect of one independent variable on the dependent variable, okay? So a simple difference is if you have two independent variables, you look for the two main effects. So if I'm looking here at, where am I? Okay. The word type, whether it's aggressive or neutral, I would be taking the averages here as if there's a main effect for word type. So 551 plus 559 divided by 2 gives me a difference of 555, okay? For the neutral word, I do the same thing. So 562 plus 552 divided by 2 gives me an average of 557. Now I'm looking to see if there's a difference between the two averages, because that's what's going to tell me if there's a main effect, Okay. What do we notice about these two numbers? They are very close to one another. This is not supporting a main effect. Okay. Meaning, if you are asked to decipher words that are either aggressive or neutral, right? And that's all you're asked to do. There's not a significant difference in the reaction time. Remember, this is what we're measuring, the dependent variable. There's not a significant difference in the reaction time between those two types of words. One's 555, the other one 557. We're not getting too excited about that. Let's do the other one. Is there a significant difference if you are cued with an alcohol photo versus a plant photo in your reaction time of words? Okay, so you do 551 plus 562 divided by 2 is 556. Same here. 559 plus 552 divided by 2, we get 555.5. This is the difference. Now, what do we think? Is there a main effect? Do those numbers differ greatly? Is 556.5 significantly larger or smaller than 555.5?
They're close, so they'll be kind of like similar.
Yeah, so there is no difference, right? This is 1 point where no one's getting excited about that. Okay, these are about the same, right? So that is telling us there is no main effect. Okay, there's no main effect here. So whether or not you were cued with a picture of an alcohol related scene or a picture of a plant, if that is all you are doing and measuring the time to respond to words, not a significant difference. Okay. This, though, has an interaction effect, as we talked about before, but there are no main effects. Okay. Let's look at this one over here. This hopefully will bring it home for you guys. Excuse me. Is there a main effect for the drinking condition? Again, how much shock intensity are you giving compared to the amount that you're drinking? So if you're in the placebo group, right? Where am I? Right here. You average these two values. So 5.09 plus 472 divided by 2 gives you an average of 4.91. The drunk group, again, 4.91, that's the shock intensity on a scale of 1 to 10. The drunk group, you average these two values, 6 plus 7.19 gives you an average of 6.60. How does this look?
Different.
It's
Like it
different.
increased.
Yeah, there is more of a significant difference here. Now, I know these are small numbers, but my scale's only 10. So this, if we go back to the original example where I started with, was one independent variable to one dependent variable, and this was one of them. So if you're in the drunk group, right, the amount that you've drank, drunk versus not, impacts how much shock intensity you're giving to someone else. Okay, so there is a main effect. The drinking condition has a main effect on the dependent variable. The other one is body weight. Now we're stripping away alcohol. Just based on your body weight, are you more likely to shock? Okay, so I average these two, which gives me an average of 5.55. I average these two, which gives me 5.96. These are fairly similar together, right? Within 0.4 of one another. So there is no main effect of body weight, which kind of makes sense, right? Whether you're light or heavy is not going to impact your shock intensity. Okay. This is another way you can look at it, okay? This is looking at the interaction, okay? This was our alcohol and plant aggressive and neutral example. If we're taking the results of this, between these two, there's a difference of -11. Between these two, there's a difference of 7, okay? So -11 is smaller than 7. There is an interaction effect here. Again, you're not going to be asked how to do that. Wait, that's not what I want. Hold on 1 second. Let's erase that. Go here to here. There we go. Okay, so I don't know if you guys remember what this looked like, but it was like that, right? The scores were like this. that showed an interaction effect. That's really all I want you guys to grasp, is if you're seeing it in a graph, you can say there's an interaction effect. Do you remember what this graph looked like for young drivers on cell phone versus not on cell phones?
That
Wasn't
was
it parallel?
It was two parallel lines, exactly. So performance or braking onset was significantly higher if they were on cell phones for both conditions. And it was lower for both conditions. But again, if you look at the difference here, 132 and 174, they do not cross over. So this one, there is no interaction. And the way, again, you can figure it out mathematically, but the best thing, what I want you guys to know is being able to identify it. So if you see a graph like this, you can say, oh yeah, there's an interaction. You see this graph, ooh, don't know what happened there. You go, no interaction. Those are just main effects. Okay, that's the goal. Okay. This is depicting the same thing. So detecting interactions from a graph. I just finished talking about all that. This is the way you would be able to detect an interaction. If the lines are crossing, you can see it. That is an interaction. If they are not, they're just parallel, there is no interaction. If you're given a bar graph, the other way you can see that is if they are, there's a swap as to which bar is highest between the two conditions. So see here, our neutral word bar is the tallest between the two in this condition, and then it gets swapped here, right? That's indicating to us there's an interaction effect. In here, the pink bar is shorter, the younger driver bar is shorter in both conditions compared to the older driver bar. So the difference here, like it's the yellow one's always taller than the pink one. There's no switch there with it. Okay. Does that make sense?
Mm-hmm.
Okay. I am feeling concerned with how much material we need to, it's 2:15. Can we take a 15-minute walk around, get your brain fresh and new, grab something to drink, and then come back in 15 minutes?
Yeah.
Let's make it 2:30 so that we're not coming back on at like 2:26. Okay, we'll see you guys all in 15 minutes.
Okay.
Whoops.